So good morning students, welcome back. Today we will discuss the combination of cells from third chapter current electricity. So let's start the topic. First of all discuss the series combination. The topic is combination of cells from current electricity, and first of all we are going to discuss series combination of cells. Okay. So look at students, first of all I am going to explain the circuit diagram. We are having two cells having EMF E1 and E2 are connected in series, having internal resistance R1 and R2 respectively, and all are connected with an external resistance capital R. That is the external resistance. R1 is the internal resistance of E1 and R2 is the internal resistance of E2. Okay. Now students, suppose total current is I, that is flowing through the circuit. Okay. Now students, whenever there are internal resistance there, okay, are connected in circuit, whenever the internal resistance are connected in circuit, in that case they are connected internal resistance in circuit, in that case potential decreases. In that case we have to use potential difference by the formula V equals to E minus IR. Okay, so using this formula, okay, we did before for terminal voltage, EMF and current and resistance. So look students, I am going to use for first E1 cell. So what will be the formula? V1 equals to E1 minus how much current is there? I, and resistance R1. Actually we took potential difference of cell, EMF of cell and potential produced by this resistance. EMF of cell is E1 and potential of this resistance due to this resistance, due to this internal resistance IR1, current into resistance. So we took potential difference of these two factors, cell and internal resistance, E1 minus IR1. That is the potential difference for first cell. Similarly, what will be the potential difference for second cell? E2 minus IR2. E2 minus IR2. We took the difference of the potential of cell and internal resistance, okay, using this formula. So this is the potential difference for first and potential difference for second. What should be total potential difference? We'll add V equals to V1 plus V2. As you know by Ohm's law, Ohm's law is always applicable for external resistance for terminal voltage, V equals to IR. So here instead we can write IR by Ohm's law and V1 and V2 that we found from first and second equation. So V1 will write as E1 minus IR1 and V2 will write as E2 minus IR2. Okay. Now students, transfer minus IR1 at that side plus IR1, transfer minus IR2 at that side plus IR2, and there will remain only E1 plus E2. So look students, what we'll do, I will common, so remaining term is what? R1 plus R2 plus capital R. We required current. Okay, for subjecting current it comes in denominator, so E1 plus E2 upon R1 plus R2 plus R. Okay, so we got the first formula. Now you can take a screenshot of this complete description because I'm going to remove this portion. Okay students, now see. Look at students. E1 is the EMF of first cell. E2 is the EMF of second cell. Let E1 plus E2. E1 plus E2 is E. That is total EMF of both the cells, that we assume. So E1 plus E2 will write as E, total EMF of both the cells. Okay. Similarly, R1 plus R2 will assume as small r. R1 is the internal resistance of first cell, R2 is the internal resistance of second cell, while small r the total resistance, internal resistance of both the cells. So here we'll write small r and there remains capital R. Here we are connected two cells. Suppose if n number cells of there, okay, suppose if you are given n number of cells. So look students, if we are given E1, E2 till En, so and if n number of cells is there, the total EMF will be what? N times of E. So write I equals to n times of E, and there internal resistance, okay, R1, R2, R3 will be R. If n number of cells are there, the internal resistance, number of internal resistance will be n. So R multiply with n. NR will be the total internal resistance of all the cells. But external, that always remains same, only single resistance. Because if n number of cells are there, it will be n number of internal resistance, but external resistance will remain same. Okay students, so n multiply with E because n number of cell, n multiply with small r because n number of internal resistance, but external remains same, single resistance that you see. So we got the final form, okay, Ne by Nr plus R, where n is the number of cell, E is the EMF, small r is internal resistance, and capital R is what? External resistance. Okay students, now students we'll discuss the second combination, parallel combination of cell. Okay, so look, as you can see, two cells are connected having EMF E1 and E2. Both the cells are connected parallel with external resistance R. R1 is the internal resistance of E1 and R2 is the internal resistance of E2. Look at students, I1 is the current flows from E1 and I2 is the current that is flowing from the cell E2. Both will add at this point. Both will add at this point, and total current will flow as I1 plus I2. And again divide I1 and I2. It will complete its circuit. Okay. So two cells are connected parallel having EMF E1 and E2, and their respective internal resistance are R1 and R2, and having external resistance R. What should be total current? We can write total EMF by total resistance. As a total EMF, E1 plus E2, that we assume as E. Total EMF is E1 plus E2 as we assume as E. So instead total EMF will write as capital E. That is the total EMF of both the cells. And look at students, as a total resistance, we are having two types of resistance, internal and external. So capital R is what? Capital R is external resistance, and R dash will be the internal resistance of all the resistance that are connected in parallel combination. Okay students, so see students, capital R is external resistance and R dash, that is total internal resistance. Okay, how can we find total internal resistance? Look, we are having R1, okay, we are having R2, and till we are having Rn. All are connected in parallel combination. So what should be total? We applying the formula of total resistance in parallel combination, 1 upon R equals to 1 upon R1 plus 1 upon R2, R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 till n times 1 upon R. So 1 upon R1 plus 1 upon R2 till n times 1 upon R. And generally we'll use the n terms. These will be neglected. We'll use the n terms. 1 upon R dash is n upon R. We require R dash reciprocal both the side. So we'll get R dash equals to R by n. Okay, so we got total internal resistance of all the resistance, okay, that are connected in parallel combination. Okay students, now put in that equation first. We got total internal resistance, that is R upon n. So here I'm going to write R upon n. On taking LCM, okay, LCM will be n. So NR plus R. N comes in multiplication. Okay, we'll shift it, we'll transfer. So finally we'll get I equals to n times of E upon n capital R plus small r. This will be the current when two cells are connected in parallel combination. Okay students.